All right, this is the Algebra 1 Unit 4 Lesson 2 video, and this is kind of an introduction to linear functions. So we talked about in the last lesson what a function is, and we're going to look at a particular type of function today called linear functions. So linear function is a type of function where there is a consistent change in x and y. In other words, every time the x or the domain changes by a certain amount, the y has a change that is also consistent. So if I move the x up by 1, the y might move up 3. And every time I move the x up by 1, the y might move up by 3. And that's kind of what they're illustrating here in example 1. You can see here we have x values that are increasing by 1 each time. Every time I go from one x value to the next x value, I'm going up by 1. You can see that here. It's consistent. And it is paired with a consistent change in y. There is a consistent change in y of plus 3 for each consecutive y value. This is what we're looking for when we look at linear functions. We want the changes to stay consistent and to be kind of like matched. But each change is going to be 1 up for the x, 3 up for the y. So that stays consistent. So then that's one main sort of component. Whereas if you look at example 2, the x values are changing by 1, but the y value is changing differently between each number. So that would not be a linear function because there is not a consistent change in y for every change in x. So that's kind of one main component of linear functions. You can do the same, use the same concept when you have ordered pairs. And it's really just written a different way. In fact, I could write this as a table if I wanted to of x, y points. 7, 5, 6, 6, 5. So this information here could be represented as a table as well if I wanted to. And then again, the key here is that we're looking to see what's the change. Well, it's going up 1, up 1, up 1, and then it's going down 1, down 1, down 1. So these are consistent. There is a consistent change between y and x. So this would be a function. So feel free to do that however you want, and you'll have examples like these in the practice on the second part of this lesson, where you will have these tables. And again, you need to determine if the change is consistent for the x and for the y. If the changes are consistent for the entire table, it is a linear function. And then the y or y not is what we just talked about. And then you do the same thing down here with number 5. You need to determine the common difference. The common difference, again, is that change. How are the x's changing versus how are the y's changing? And again, if the change is consistent, then it is a linear function. So that's kind of one main concept in this lesson. So make sure you're using that. And then they talk about one of the forms of linear functions, which is called the standard form equation. The standard form equation of linear functions is written right here. A, B, and C are going to be some numbers. So for example, you might have 3x plus 8y equals 12 or whatever. So this would be a linear function in the form ax plus by equals c. So a would be 3, b would be 8, and c would be 12. Also listed here is a list of basically no-nos. These are things that cannot happen or things that are requirements for linear equations. So I'm going to kind of just summarize and say the following. You cannot have any exponents on the x, or x or y, nor can x or y be an exponent. So looking at the 6 examples they have here, if they're asking us to determine if these are linear functions, right away, because this x has x squared, that's not a linear function. Because this x is in an exponent form, that's not a function. So that's one way to kind of rule things out. So that takes care of these two. Also, x and y can't have a square root. So that rules out this last option. That is not a linear function. X or Y cannot be in the denominator. That's right there. And lastly, X and Y cannot be multiplied together. You see that right there. So this is the only one that is a linear function. And so you'll be doing the same thing in your lesson. You need to go through this list. I will put, again, a summary of that in the notes of kind of what are the requirements for a linear function. So I'll put that list in the notes page. So that's kind of the main idea there. And then they want us to learn how to rearrange equations kind of in a very basic way to become linear functions. So I'm going to go through some examples of that really brief. There's a lot of extra stuff, I think, in this lesson. So read over some of this, and we'll talk about graphs here in a second. But first, I want to talk about what to look for when we are putting things in standard form. Is that a drawing? So again, the standard form of linear functions, or rather linear equations, is ax plus by equals c. So if I'm given a linear function that looks like this, let's say it's 4y equals 10 minus 3x. So in order for this to be in standard form, I need to move things around so that the numbers are in the order x, y equals constants. So I need the x and the y to be on the same side. I need the constant term to be on the other side. So right now the y is on one side and the number and the constant and the x on the other. So I need to move the x to be on the same side as the y. To do that, using algebra, I'm going to add 3x to both sides. And don't overthink this. This 10 is going to stay. And these are just going to be written as one single line. So we're going to have 3x. I want to put 3x because I want that to be first, plus 4y equals 10. And so now that is now in standard form. Let me kind of make room over here for another example. So let's say I have the following. Let's do another example. What if I have 3x minus 4 equals 2y? Okay, now things are in the wrong places. I need to get my 4 onto the other side to be where the c is. So we'll do that first. We'll do plus 4, 3x equals 2y plus 4. We're still not in the right form. We need my y to come over as well. So we'll move the y over, again doing the opposite using basic algebra. Cancels that out. So I end up with 3x minus 2y equals 4. And that's good. Now don't be alarmed that it's a minus 2y instead of a plus 2y. The plus sign here is not always going to be plus. It could be minus as well, depending on whether or not b is a positive or negative number. So just be aware of that. So that's kind of the basics of just getting these rearranged. Just use those basic algebra skills. When you want to move something from one side of the equation to the other, you just do the opposite to move it across. All right. The other thing they have here is they want you to be able to make comparisons between the graph, a table or a list of points, and the equation of linear function. So we're going to practice this using Desmos. So I'm going to jump over to the graphing calculator. And we're going to type our y equals 2x plus 5 equation into this graphing system. I recommend Desmos just because it's kind of, I think, the easiest to use. It's a lot easier. It gives you a lot more information than a graphing calculator does. So let's go in and we're going to do y equals 2x plus 5. And if you need to use the toolbar, you can bring it up like this. I'll just show you how I did that again. Y equals 2x plus 5. So there's my graph. And then it asks the question, which of the table of values represents the equation 2x plus 5? So think about it this way. Each of these lines represents a point on the graph. So like I'll just do this first answer choice as an example. Let's see if these are on the graph. So -8, 13. So I'm going to go over here, and I'm going to look at -8, and I want to see if the y value is 13. So -8 is about right. There it is. And there's -8. I just zoomed in. -8 has -11. It's not negative. It's not positive 13. So I already know that's not the answer choice. But if I continue, I can go -7. Again, I look for -7 on my graph. -7 is going to be right there. -7 crosses at, there it is, -7, -9. Notice how I'm just clicking the line and I'm dragging to find that point. -7, -9. That doesn't work. That says 11, so that can't be right. So already I know the first answer choice is not correct. So you need to go through, look for each point on the graph until you find the table that has points that are all on the line that you see graphed here. So you're just kind of dragging and you're finding those points to see if they match on the line. That's what you're doing in number 1. Number 2, you just need to look at these graphs and see which one of these graphs looks most like the graph you found when you graphed it on Desmos. And that's pretty much it on that. So that's pretty straightforward. This one, match the scenarios with the function rules. I'll just say it this way. You need to find the equation that illustrates this concept. So it's pretty straightforward. Now, I don't want to overthink this too much, but you know that if you're looking for something about 10 cents for every golf ball, that somewhere in that is going to be 10, right? And for instance, here, like repairman charged $40, you know 40 and 20 are going to be somewhere in that equation. There's only 3 options. So I'm sure that if you just use common sense, you guys can figure this one out, which of these function rules matches the equation. So just find the numbers that match the thing you're looking at. So that's this lesson, and then I'll just jump to the next part of this lesson because you need to open the attachment, and the attachment looks like this. And I would just complete these on a separate sheet of paper, and then you upload those to the Buzz system, and I can see your answers that way. So that is it for lesson 2. Please reach out to me if you have questions or need help. I'm here.